Welcome back to the next episode. Since last time, I've added a couple more things. I'll quickly run the program so you can see them. Basically, we can sum it up as a viewport behavior, which is pretty interesting to add. I've got it clearing to pink now, just it'll make sense in a second. So if you have seen the last video, you'll remember we had a grid. It was just centered in the bottom down here, drew the entire level. Now it centers on the player. It can move you around. All the same behaviors work, so you can click around in here. And then I've enabled, I guess, like detachable viewport. So if you've played lots of roguelikes, you'll know it's often useful to be able to like detach from the player and go have a look somewhere else. So if I click look, either with the mouse, I can recenter on a different tile, so I can come all the way up here. Or I've added buttons that will let you move around as well. Click play or recenter you back in, and then we've got zooming, so you can zoom in, you can zoom out like unreasonably far, you can zoom in as far as you want. That everything just kind of adapts. You'll notice the grid has like a size and it neatly trims at the edges. I'm moving on a wall, wondering why it's not working. And then you can reset back. And I think that's everything I've added. It's everything I can think of. As always, I will put the tagged commit in the description of the video. So if you're curious to see any of the details, you can dive in. I have made some notes in the README of how I found making those changes. So you can see here my little to-do list. We've done all the viewport bits. I've really made an effort to take on the kind of just write the simple thing, the simple way attitude. Honestly, it's been surprisingly difficult. I think the kind of knee-jerk desire to start refactoring things and adding structure and breaking things up sets in really often. So I'm deliberately making an effort to keep it simple and very straightforward. Possibly too much so. So I think one thing I have found, I think I make a note in here, I think the playing view logic that we're about to scroll through is getting pretty hairy, right? We're starting to get very indented blocks. There's lots of ifs inside of ifs. But I'm trying to, I guess, in this blog down here, one of the things he says is the code that he's starting from, he likes that it's literally just written out. So if you were going to tell me how to draw the thing, it reads like that set of instructions. And then he said finds that to be the best starting place, and then you start adding structure from there to compress it down, land somewhere that makes sense. So, I guess do not judge. I'm considering this a bit of an experiment. This is going to get hairier before it gets nicer, but hopefully where we land actually then ends up being particularly nice. One thing I would say is that I have found it, I don't know where I've written it in here. I found it surprisingly easy to just come back in and extend and tweak. And I think that this is his point, that the lack of structure being imposed on the problem early makes it very malleable. So you can kind of squish it into the shape you need it in. And then you let the structure come later as your use case kind of crystallizes. So that's been an interesting experience. I guess this is all of the code. If you watched the last video, you'll have seen I pulled, I guess, like action handling out from the drawing so that we're not mutating state mid-draw, because I think that may get scary quickly. So when a button or some interaction wants to trigger an event to happen, it sets this action with a type and an optional data, and then we have a handler at the end that handles them all. And like I say, I've done this very manually. So you come down through playing view. So when you click the start button on the main menu, we put the game into playing mode. We then draw playing view. This is the action for playing view. It's local to this screen. And I think this might make sense to do, is to try to keep these action handlers local to their view so that they're not chatting across each other too much, just for, I guess, like mental model sake. We'll see if that stays true. If It might end up being that that wants to be pulled out, but I think an action being tied to the current UI being shown makes quite a lot of sense with the way we're doing things. So, and then yeah, like I say, basically every one of these goes through, and it's very much like I'm defining a cursor position, and then I draw a button, and then I move the cursor, and I draw the next button. When I want to have a row, I'm putting them in little scopes just so I don't get naming collisions. And then yeah, same thing. We just define like the cursor position, then we do the draw. It sets its action type, and then it updates the cursor position so the next draw can happen. Makes it very easy. So you can see there I've got a couple of rows of buttons. And then yeah, all our handlers come down here. So currently all of our logic's pretty simple. I guess grid clicks are most complicated logic so far. Even that's not too scary. So that's kind of structurally how it all works. It's extending off what we saw in the last one. Viewport actually required very little stuff. There's some extra stuff. I'm throwing everything just into the kind of global game state for now. Again, with this logic of don't impose structure early. So we'll see how that goes. If I had to point to anything out of this that was actually pretty hairy, trimming the grid buttons at the edge of the grid was probably like the thing that took the most like attempt and thinking. I underestimated the problem. I think I've done a bit of software rendered stuff before, where you're kind of sampling from, I guess, your like quote unquote texture, and then writing to your output. And obviously, if you're doing that, and you have access to everything at every point in that, you can kind of trivially say like, and if I'm outside of this box, this predicate is now failing. I don't actually populate the output pixels. So drawing part of a thing you're drawing is quite easy. That's very different when you're doing the stuff through the GPU, because obviously you're defining everything you're going to draw up front and then shipping it to the GPU to handle it. So you had to work out up front what you're actually going to be drawing. So if I jump to, where would it be? It's somewhere in here. Let's have it somewhere. There we go. Draw grid. You can see me in here. What am I actually doing? Just working out like what it is that we're going to be drawing. Trying to minimize how many bits we're iterating over, because I think we're about to start making the map much bigger. Then yeah, we iterate over everything. And we define this trim. So this trim is saying, basically, look at the grid, like my container, then look at where I would be drawn if like we were just drawing me naively, and work out how much I'm overlapping to the left, to the right, to the top, and the bottom. If I don't overlap at all, just continue. So we skip the draw, which I think probably is worth doing. I don't know. That might be worth like trying and seeing if this actually makes an impact on run times. But it saves running a load of code, so I'd imagine so. The uncertainty there is probably down to like branch prediction, right? That do you end up losing some like cache efficiency? But we'll see. Currently, the game's so simple it doesn't really matter. I don't know that there's a right answer there, so we'll wait and see. And then we have in here handling to say if I'm the player, draw the player. If I'm a grid tile, draw the grid tile. Both of these call the same code. Let's just make that bigger, which works out what color it wants to be. And you see here, we're now passing in this trim to do some working out to say, okay, how big is my like actual container that I'm actually going to draw the character in? And then we can draw that. And then a lot of the pain is really hidden inside of this draw trimmed character that I've added. But first I tried just adapting my existing draw character. And actually I've just split off a separate function. So draw character still exists down here. To do the previous behavior where I'm drawing a string and there is no trimming. Pulling these into a single thing might be sensible to do later. Currently there's some repetition, but I don't know, I've not thought about it yet. And then what is this doing? Some voodoo to work out. So we first work out how big the character is going to be. Maybe I should draw this because I think there's a few moving parts here. So what we've got is we've got the screen. Can I use a draw rectangle? Yeah. You've got the screen. Then inside the screen, we've got the grid. So if so all of this is kind of out of bounds, right? Like we're not going to draw any of our grid in this because it's got to room to draw all the rest of our UI. The question is, if I am drawing this top right tile and it's meant to have a letter in it, how do we work out exactly what we need to draw? So that tile actually has two parts. One is its background. So it's got a background quad like this. And we need to work out basically like the, oh my God, the intersections. Tell I don't use this drawing pad very much. We need to work out these intersections so we can snip these off and set our new position and dimension that we're actually drawing when we define the drawable. Because if you remember, the pipeline we have is our game logic defines drawables that say, here's my position, here's my dimensions, here's all of my texture data, and then we generate the vertices and indices that we ship to the GPU from that. So we need that all that data up front. These are actually not textured. So currently it's simple. We just need the position, dimensions, and the color, and then we can draw the background. The thing that actually caught me out when I first did it, I had to go back and rethink it, is our button actually consists of that background and a letter. That letter has its own bounding box like this. So every button with a character in it that we draw is actually two quads, and it's just one in front of the other. If the intersection with the trim is there, so we're drawing this, then I update my position for that quad. I can leave its dimensions alone, and I don't have to update how I'm actually doing my sampling. If, on the other hand, it's here, right, and all of this is gone, then actually what I need to do is I need to update that position, but I also need to update the UV coordinates that I'm sampling from my texture image, right? Because it is just a picture, right? You can imagine, I think we literally have, like letters in order like this. And these corners define the corners in that image that is going to sample pixel values out of. So when the GPU draws, it goes, this pixel corresponds to this bit here. So if I just update the size of this quad, what I would get is, instead of my clipped E, right, what I want is an E that looks like that and it's just clipped off. Instead, what you would get is a really squashed E that just conformed to the new quad. So there's a bit of handling to do to work out, okay, given the trim on the bounding box, what is the trim on my character box? And of course, different characters are different sizes. So relevant to our current example is a period, a full stop, is a tiny box. So quite significant trims into the container box don't touch the full stop. Whereas like our at might like really fill that box, right? Like that looks like that. Then its box is actually all the way out here. And trims really affect it. Now, I'm not going to step through this code really carefully, but hopefully that kind of gives you an idea. So you can see in here, like, what we pass in is the container's position and dimensions and trim. We pass in the details about our font that we're going to need to draw the thing. And then step one is basically going and looking up how big that font box is, and then calculating, before it was trimmed, what would that box have looked like? Given the untrimmed character box and the container trim, work out what the character trim looks like. And then given the character trimmed box, get the updated quad to draw for the background, and get me the updated UV coordinates in here for the sampling to work. And this is very easy to mess up, and if you mess it up, you get very warped and horrible looking stuff. So I had to go through this fairly carefully. But, I mean, as you could see in the demo from the start, it works, I think, just about right. Right, if I can we pull this out? Like, if I smoothly increase this, I don't see like a jump at the point that stuff starts getting clipped. It just sort of smoothly works its way in. Whoopsie. Like so. And if I put it there, so we've got like about half of that's clipped, and we move across, it all just kind of looks like I'd expect on both sides. So that's all very nice. But like I said, I think it was interesting in part because it was significantly more work than I would have guessed it was. And like I said, I think the reason being because you have to kind of work out what you're going to draw and then send it. I think what I'm used to from more kind of like software rendering logic would be at the point that I'm updating the output image, I would have some logic to do that that sort of checking. To be fair, even in software rendering world, this is probably more performant, I would guess, just for avoiding branches in that like hot loop. But you probably would end up doing this anyway. But you're kind of forced to do it earlier in this kind of GPU rendered version. But yeah, like I say, I think it's not particularly like algorithm interesting. It was more kind of, I don't know, like careful geometric reasoning interesting, I think. But good fun. Did I say all of this? Yeah, I think so. Oh yeah, the playing view code. I don't know if I'll show it. This is all getting a bit hairy, right? Like that's a lot of indenting, and I think it is just a bunch of if else's. As you're coming down this code, we are saying for the row index and the col index. So that indents us twice. We then draw each button. Within that, we then have to say, am I the player? Am I not the player? Then for each button, was I clicked or was I not clicked? So, and I think the tidying here is obvious, right? In this case, I can pull all of this out into like a draw grid tile helper. I think the next thing we add to this will do that basically. Similarly, I think there's probably some tidying. I always forget. I defined a rect type because there's lots of rectangles in our logic. I mean, if you think this logic is essentially all rectangles, and so you have just lots of pairs of positions and dimensions. I always forget it exists. So all of the code, more or less, defines like a separate pos and dim. Or I can find an example quickly. In here. Yeah, like all of this sort of thing. Like actually here, I've even unpacked the one place that I'm using the rect. I've unpacked into two different ones because I don't know. It's become kind of habit. So I might do a pass through and just replace all of the pos dims with rects and see if that's easier to reason about. But small differences, right? It doesn't make a big difference. You can see here, draw rect doesn't even take a rect. It takes a positive dim. So I think there's a lot of smaller tidies like that need doing, but the kind of core changes are coming along quite easily, which is nice. In terms of what's coming next, I think just more like gameplay code, right? We're going to start actually building the game out. So we've now got the drawing in place. We've got our viewport in place. We've got basic player input in place. We're going to generate a very simple level by just generating a set of boxes and a set of corridors between them, put you in one, and then we'll start working out like how we do line of sight and how do we want to show tiles that you have seen but can't currently see. A mini map I think would be really interesting to play with. Like, I think this is the next sort of chunk to get that sort of basic game-like stuff implemented. And hopefully this comes along quite quickly. So I will catch you in the next one and let you know how that goes. Yeah, as always, if there's any questions, the tag to commit should be in the description. I'd be happy to clarify anything or even just chat about anything in the comments. Yeah, I hope you've enjoyed. We'll catch you next time.